Good day viewers, and you are welcome to MLT channels. Today's subject matter is chemistry and the topic of discussion is saturated hydrocarbons. You are all welcome on board. Alright learners, without wasting much time, let's quickly dive into details. And we are interested in saturated hydrocarbons. Saturated hydrocarbons are hydrocarbons composed mainly of single covalent bonds between all carbon atoms in their molecule. A very good example of saturated hydrocarbon are the alkanes. And the meaning of that is that if you look at this is an example of a saturated hydrocarbon. And if you look at the bond that exists between all these carbon atoms, they are single covalent bond. And we've said alkane is a very common example. What are now alkanes? Alkanes are saturated aliphatic hydrocarbons composed mainly of single covalent bonds between all carbon atoms in their molecule. They are popularly known as paraffin and are usually used as fuel. Alkanes have the general molecular formula of CnH2n plus 2, where N is a whole number starting from 1. The first member of the alkane series is the methane, corresponding with N equals to 1, having a molecular formula of CH4. Other members are the ethane, propane, butane, etc. On this slide, we have learned what saturated hydrocarbons are, and simply, saturated hydrocarbons are hydrocarbons that are composed mainly of single covalent bond between all carbon atoms in their molecule, and alkane are a very common example of saturated hydrocarbons. Alkanes are saturated aliphatic hydrocarbons composed mainly of single covalent bond between all carbon atoms in their molecule. They are popularly known as paraffin and they are mainly used as fuel. They have the general molecular formula of CnH2n plus 2, where N starts from 1. The first member of the alkane is the methane, having N equals to 1, and other members are the ethane, propane, butane, etc. In the next slide, we shall be looking at homologous series of alkane. Alright learners, on this slide, we are interested in homologous series of the alkane, which implies the members of the alkane series. Don't forget, in the previous slide, we have established that alkanes have the general molecular of CnH2n plus 2, and the first member, which is methane, starts from 1. Now, talking about their homologous series, the first member is when our N equals to 1. And if N equals to 1, if we substitute that here into this formula, that will be C1 because N equals to 1, then H2, that is multiplied by 1 because our N is 1 plus 2. Then this should give us C1 is the same thing as C. Then 2 multiplied by 1, that's 2 plus 2, that's 4. That gives us CH4. So that implies that the formula of the first member of the series, the molecular formula, is CH4. And the name of the first member of the series has already been mentioned earlier, and the IUPAC name is methane. That's a trivia name. The first 4 members of the series got their name from trivia names, while the other members derive their name from Latin word. Then the structural formula. To do the structural formula, alkanes are tetrahedral in shape. That carbon atom will be at the center, then it will be surrounded by hydrogen molecules. Hydrogen atoms rather. And that's the structural formula. That's the structural formula of methane. Methane has no staggered structural formula, no condense, no zigzag. So on to the second member now. So the second member of the series, that is when Rn equals to 2. And the molecular formula of that, if we substitute 2 here into this general molecular formula, that will give us C2. Then don't forget that Rn is 2. 2 multiplied by 2 now, that will be equal to 4. Then plus 2, that will be 6. C2H6. And the name of this second member is ethane. And its general and its structural formula, as we have said earlier, we always have the carbon atom at the center, and the bond between them is single covalent bond, then surrounded by hydrogen atoms. We still maintain that tetrahedral shape. And for ethene too, no staggered, no condense, no zigzag structural formula. So now let's check for ethene C2H6. Then the IUPAC name is ethene for the second member of the series. Then count our hydrogen atoms: 1, 2, 3, 4, 5, 6. Then our carbon atom is 2. So we are good to go on the second member of the series. Now on to the third member. That is when Rn is equal to 3. And when Rn is equals to 3, if we substitute for N in the general molecular formula, we shall be having C3, then 2 multiplied by 3, that gives us 6, plus 2, that is 8. So that will be C3H8. Then the IUPAC name of the third member is propane. And the structural formula of propane are carbon atoms at the center, joined by a single covalent bond, then surrounded by the hydrogen atoms. So as usual, let's also check the third member, that is when N equals to 3, and substituting 3 into this general molecular formula, we have C3H8. Then the IUPAC name is propane. Then we have 3 carbon atoms at the center that are joined by a single covalent bond, surrounded by 8 hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8. So that's that about our propane. Then propane 2, there is no staggered, no condensed structural, and no zigzag. So the fourth member, which should be the last member we will be looking at into the first class. So that is when our N is actually equal to 4. Then when our N is equals to 4, if we substitute 4 into this formula, that will give us C4. Then 2 multiplied by 4, that is 8, plus 2, that's 10. So definitely the molecular formula should be C4H10. Then the IUPAC name of the fourth member of the series is actually butane. Don't forget that in the previous slide, we said alkane are mainly used as fuel. Precisely, this butane and propane are used as fuel in as our LPG, liquefied petroleum gas, that we use for cooking at home. So to write the structural formula of butane, the carbon atoms again at the center, joined together by a single covalent bond. Then we have the hydrogen atoms surrounding them. Then other structural formula, these ones are the common structural formula. We could have the staggered, the condensed, and the zigzag, and all those other 3 other structural formulas actually started from butane. So immediately after this common structural formula, we shall look at the other 3, because sometimes in exam you could be given the staggered, the condensed, and the zigzag. So you should be able to know that they could be written in another form apart from the common form. Alright, here is our butane. Then let's check before we proceed. If it's for butane, that is when our N equals to 4. If you substitute N equals to 4 into the general molecular formula of alkanes, you will be having C4H10. The IUPAC name is butane. Then let's check the structural formula. We have 4 carbon atoms at the center, 1, 2, 3, 4. Then that should be surrounded by 10 hydrogen atoms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are good to go on the common structural formula. But it's on butane that we will have the staggered, the condensed, and the zigzag. And when we say staggered, in staggered, we will have something like CH3. We'll analyze all that. CH3, then CH2, CH2, and ending by CH3. What's the meaning of this, and how do chemists come or derive this? If you look at this, this is divided into, this is ethyl, methyl rather. We shall be talking about that when we get to alkyl, another functional group. This CH3 is actually this one. Then CH2, and there is this. Then CH2, and that's this. Then finally CH3, and that's this. And this is what chemists refer to as the staggered formula. Most of the time in exam, precisely our WAEC and NECO and UTME, this is how they usually write it. Then this can also be written in condensed form. Then how do they write that in condensed form? Okay, let's label this as staggered. Now, to write that in condensed form, we should have CH3, then we open a bracket now, CH2, then we have 2 of that CH2 into bracket 2, then CH3. And this is the condensed form of butane. Let's name that condensed. The only major difference between staggered and condensed is that this CH2 that repeats itself twice is what they have combined here. That's what they combined here. If you look at here is C2, okay? If you look at here is C2H4, CH2CH2, and the same thing here too. If you use these two to open this bracket, that will give you C2H4, and that's what they mean by the condensed. And the last one that we could have is actually the zigzag form. Then in the zigzag, we'll have something like CH2, then CH2, so up here now we have CH3, then down here too we have CH3. And this is the zigzag structural formula of butane. Don't forget that all these other structural formula of condensed, staggered, and zigzag started from butane. This is that of the zigzag, and this is still the same molecular formula. We have CH2CH2, that is C2H4, then plus CH3, that is C3H7, then plus C3, that's C4H10. So these are the other structural formula of butane. It could be in staggered form, and we have analyzed that. It could be in condensed form, and it could also be written in zigzag form, apart from the common structural formula that we have here. Alright, on this slide, we have learned about the homologous series of alkane, and we started by their general molecular formula, which is CnH2n plus 2. Then the first member of the series is alkane when n equals to 1, and if we substitute n equals to 1 here, that gives us CH4. And the IUPAC name is methane, and there is the structural formula. It cannot be written in staggered, condensed, or zigzag form. Then the second member is when n equals to 2. You substitute 2 into this formula, that should give us C2H6. And the IUPAC name is ethane, and there is the structural formula. It can also not be written in form of staggered, condensed, or zigzag. The third member is when n equals to 3, and that is C3H8. The IUPAC name propane, and there is the common structural formula. That can also not be written in form of staggered, condensed, or zigzag. While the last that we shall be looking at today is when n equals to 4, and the molecular formula is C4H10. IUPAC name is butane. The first structural formula here is the common structural formula. But other ways in which this common structure can be written is staggered form that we have here. It can also be written in condensed form that is here, as well as the zigzag form. I hope you have gained one or two things so far in today's class. If yes, let's now assess ourselves in the next slide, where we shall be looking at some questions. Now, on this slide, we want to assess what you have learned so far, evaluation. And we have the first question that says, define alkane. We have defined that earlier, and if you have gained one or two things, you should be able to define that. Then we have the second question that says, an alkane has a molecular formula of CnH22. So we don't know the alkane because we don't know the number of carbon atoms that is present. So here now comes the first question. What is the value of N? So how do you get that? To get that, just equate this to the general molecular formula, which is CnH2n plus 2. Then you do your elementary mathematics, Cn will cancel out. Then do your elementary mathematics, that should give the value of N. Then having gotten one N is, the next question is, you should write the molecular formula and the structural formula of the alkane. You write its molecular. Once you know the value of N, you should be able to write the molecular formula and the structural formula of the alkane. Then the C part now says, give the IUPAC name of that alkane. So the IUPAC name, you should state that. And the final question for the day is that state the IUPAC name of, you already have the compound CH3. It is written in condensed form, CH3 into bracket 3, CH3. And that will be all for today's class. 23 minutes just gone now, like 23 seconds. I remain my humble self, Engineer Oladepo, your host, and your amiable online tutor. If you have gained one or two things in today's class, do not hesitate to join us in the next lesson, where we shall be looking at isomerism in alkanes. Alright, for bookings, you can chat or call Engineer Oladepo on 080 670 76871, or you can visit our head office. We are at Omega Building, opposite Gasland Nigeria Limited, Obafemi Awolowo Way, Malete, Ibadan. Or you can use our website www.mlttechspace.wordpress.com. Until I come your way again, don't forget, at MLT, we are determined and dedicated to achieving excellence in all our endeavors. Bye for now.